here at University of Houston Clear Lake. And unfortunately, I can't stick around long because I'm hosting another talk upstairs at 8 o'clock. So that is, also I wanted to mention to everybody that there is this thing going on upstairs celebrating the shuttle and American Icon. And that is going to be going on until September 28th. And you can see that in Atrium 2 and on the higher floors over there. And for those of you who are here, make sure you're here for the right talk tonight, because I know it's going to be a very confusing night. If anybody's here to see Jeff Bennett, that's going to be upstairs in room Bayou 3326. For the rest of you, this is the right place to be because there's only 2 physics talks going on tonight. I'm here to introduce Dr. Stephen Mackwell, and he will be introducing your speaker for tonight. Dr. Mackwell is a member of our advisory board for the physics department here at University of Houston Clear Lake. And when I started the advisory board, he was one of the first people I chose to sit on this board. And that board gives us a lot of valuable advice on how to run a program and on what kind of things to develop that will give the most value to our students. Dr. Mackwell received his BS in Physics and Mathematics and an MS in Astrophysics at the University of Canterbury in New Zealand. He also received a PhD in Geophysics from the Australian National University and did a postdoc fellowship at in Material Science and Engineering at Cornell University in New York. He then moved to Penn State University, where he was a professor in the Geosciences department. And then in 1998, he moved to Germany, where he was a professor and institute director. Since December of 2002, Dr. Mackwell has served as the director of the Lunar Planetary Institute here in Houston, and he is also an adjunct professor in the Department of Earth Science at Rice University. You know, he has numerous panels and advisory groups from NASA and other federal agencies, but the one that we remember him best by is what he's done here for us here at UHCL in helping our physics department grow. And he is a fellow in the American Geophysical Union and the Meteorological Society of America. So with that, I'll turn things over to Dr. Mackwell.
Thanks, David. It's my pleasure to be here tonight to welcome you all. It's a great group. So many people, so many faces. Many of you are familiar. Some seem new to me. We really enjoy reaching out into the local community and having people come in and participate in the seminars, particularly the public seminars that we hold and the activities that we do through the year. And it really is great to see such a large turnout on the first of the series that we're running right now. I wanted to just say a couple of words about the Lunar and Planetary Institute. We've been around since Apollo, where the Institute itself, which is now actually occupies a corner of the block just over here. Many of you know it. We've been there since the early 90s. Before that, we occupied the West Mansion, which sadly is decaying over there on NASA Road 1, but beautiful old building. The LPI was originally created to act as a connection point between the international university community and NASA during the Apollo era. The idea being that Apollo was bringing back so much great imagery of the moon, we're bringing back samples from the moon, and in order for NASA to be able to make those resources available to the community, the LPI was created to facilitate that and to bring people literally from all over the world to be able to access those the facilities and the samples in particular. We've grown over the years and we've broadened our purview. We now have a very diverse group of research scientists who do outstanding work at the Institute. We have a large education and outreach group. This is one of their activities here tonight. We also have resources in terms of a lot of the imagery that has been collected since Apollo. And we're doing lots of research-oriented things, running meetings also for NASA. So we pride ourselves for the services that we provide for NASA and for the scientific community, and also the things that we do in the local community as well. And this Cosmic Exploration Series is something that we started up, that we enjoy doing, and we really appreciate you participating in it. This presentation tonight, as I said, is the first of this year. We have another 3 scheduled. There's another one scheduled coming up later in the fall. It's hard for me to think of the fall. This is Houston. Fall doesn't, the fall is something that happens in the northern part of the country, not down here. The next seminar in the series is going to be New Understanding of Solar System Evolution. And then we have 2 more in this series. We're happening in the spring. One is on the Grail mission. I was out at Kennedy recently, and they delayed the launch, and then they delayed the launch, and I had to fly back to Houston, and then the launch went off. I know a lot of people have had that experience, either with shuttle or with robotic launches. So we're going to have a talk about the Grail mission to the moon, which is a great and fascinating mission. And then the second one in the spring is on the Dawn mission. As many people may know, Dawn is another robotic mission. It went into orbit at Vesta recently, and it's sending back most amazing images of the surface of one of the major asteroids in the asteroid belt. So we're seeing, for the first time, up close and personal, a fascinating new body, and we'll have a presentation on that in the spring. So anyway, we want to get to our speaker. So with no further ado, I will ask Andy Shaner, who's a member of the education group at the LPI, to come up and introduce her. Andy?
Thank you, Dr. Mackwell. I was at Grail too, and I got to see it go up. It was pretty cool. I appreciate it. So 400 years ago, an Italian mathematician and physicist pointed this newly invented thing called a telescope up at the heavens and observed some things that really challenged the long-established views of the solar system, of how our solar system worked. Today we're doing the same thing, but with spacecraft. And so sometimes I wonder what Galileo would think today, what we know now compared to what he knew 400 years ago. Tonight we'll hear from Dava Sobel. She will talk about humanity's view of the solar system, how our views of the solar system have changed through history, and in her words, how myths became hypotheses, how the Earth was removed from the center of the universe, and how today's spacecraft continue to revise the far horizon of the landscape of home. I want to take a moment just to kindly ask you to mute or turn off your cell phones for the evening. We will have a Q&A session when she's finished. Unfortunately, it's kind of difficult to get to the mics, so if you've got a question, shout it, and we will repeat it, and then she's more than happy to answer it for you. And we're very fortunate and want to thank UHCL for providing the auditorium for this evening and for providing parking without getting ticketed by the campus security. However, that does end at 9:30. I just want to point that out. Born in the Bronx, Dava Sobel graduated from the Bronx High School of Science, which she professes to be her best academic credential. She took biology, chemistry, and physics and a drafting class, but somehow she decided not to take the history and development of science, which was offered, which I find ironic. That's exactly what she writes about. She has spent her entire professional career as a writer. Straight out of college, she went to work for IBM as a technical writer, but soon, very quickly, moved into journalism in 1970, just in time for the first Earth Day, and when she found herself writing about environmental issues. Her 2 favorite full-time jobs were science writer for the Cornell University News Bureau, where she wrote about everything from astronomy to veterinary medicine, and staff reporter in the science news department of the New York Times covering psychology and psychiatry. Her most unforgettable assignment at the Times required her to live 25 days as a research subject in a chronophysiology laboratory where they boarded up windows and specially trained technicians kept her from knowing whether it was day outside or night. Just kind of like working on a Mars mission. The publication of Longitude in 1995 transformed Dava into a full-time author of books, which she greatly enjoys due to the more in-depth research required for such writing projects. The success of Longitude was followed by Galileo's Daughter in 1999, The Planets in 2005, and A More Perfect Heaven, which hits bookstore shelves this Tuesday, September 27th. All three of Dava's books have been successful and rather influential. Longitude helped place a memorial to John Harrison in Westminster Abbey in 2006 and inspired a movie by the same name in 1999. Astronomers who read Galileo's Daughter named a crater on Venus for Soeur Maria Celeste and named a feature on the asteroid Eros for her mother, Maria Gamba. Because of the planets, an asteroid discovered in 1994 by David Levy and Carolyn Shoemaker has been officially registered as asteroid 30935 Dava Sobel. While she enjoys events such as lectures and book signings, Dava believes writing is really about sitting alone in a room, and the highlights occur in that room with no one else's witness, in the small moments of the day when the work goes well. I experienced some of the most memorable of such moments during the years spent on Galileo's Daughter, especially in winter when the early morning hours were dark, and I could enter my office half believing it was Soeur Marie Celeste Convent of San Mateo. Ladies and gentlemen, please join me in welcoming Ms. Dava Sobel.
So, yes, I've been invited to speak about this topic, humanity's changing relationship with the solar system. And solar system is the operative word there because that is a relatively modern term. And coming to view the planets as part of a system has been part of that changing relationship. And certainly my relationship changed a little bit today because I got to go over to Johnson Space Center and see the room where they keep the moon rocks. And that was very thrilling indeed. I'm just curious, does anybody know what phase the moon is in now? You can just call out. Well, it's clear that everybody in Houston is aware of the moon, so we will leave it at that. The background for this image is a painting by my friend Lynette Cook. And if you follow Astronomy Magazine or Sky and Telescope, you have seen her work frequently. And she often paints exoplanets for their discoverers, because most people have no idea what an exoplanet looks like. They're discovered not visually. But she, in talking to them, can get a good sense of what the place is probably like, and she paints the portrait for the discoverer. And she worked with me for my book about the planets in 2005. Unfortunately, I had a very sad experience with that book, and her wonderful paintings were not included in the hardcover edition of the book. Something that we in publishing call editorial judgment. But I was able to convince the publisher to include them in the paperback, and I'm going to show some of them tonight as part of this talk. Did you all build something like this at some point? I certainly did, and mine didn't look anything near as nice as hers. Even when she tried to make it look like a child's creation, somehow it's still an awful lot better than what mine looked like. So the solar system, that word, that phrase, actually dates to 1704, is the first recorded use of it, which is a long time after Copernicus suggested that all these bodies actually do move around the sun and are influenced by it. So in the beginning, before there were electric lights, this is what the sky really looked like. It was certainly the greatest show on Earth. And if you paid attention, you saw all sorts of things and had a sense that some great force was at work behind all that grandeur and beauty. If you watch the moon, certainly you notice that the moon changed in certain reliable ways every certain number of days. And you could actually put the moon to practical use for timekeeping. This is an early calendar. It's about 30,000 years old. So attention to the bodies of the heavens goes way, way back. And of course, every now and then, something truly remarkable happens to the moon, and it gets slowly swallowed up in shadow and then turns this beautiful color orange. And this was so striking to people that detailed records about lunar eclipses go all the way back to the 8th century BC. And mythology about the moon, about the planets, is so ancient that it's actually hard to know whether people made up gods around the bodies they saw, or if they had their imaginings about gods and then transferred those attributes to the planets. This is another one of Lynette's paintings. The Mercury chapter of the planets was all about mythology, because Mercury is the god mentioned most often in the Greek myths, and he was a go-between between the world of the living and the dead, partly because he's always visible just before dawn or just after sunset. And so she put some of the symbolism of the Greek myths onto a Grecian urn. And there were myths about all the planets. This is actually Io. Before we knew what Io looked like close up, Io was a beautiful young woman, and Zeus, Jupiter, had designs on her, but knew about his jealous wife, Juno, so he either disguised himself as a fog, which he is doing here. You can see his face and hands, or in some stories, he just caused a fog to cover up their assignation. Try to remember this. We will get back to these characters later. Every culture has some kind of mythology, ancient record keeping about the planets. This is part of the Dresden Codex, part of a pre-Columbian Maya calendar. Observations mostly of the planet Venus from 11th or 12th century. And if you are rooted on the Earth as we are, and you look out at the night sky and you watch the moving lights of the planets against the background of the stars, you could convince yourself that everything is in motion around the Earth. If you pay really careful attention, it's hard to account for all the motions that you observe. But the sense that the Earth was at the middle of a nested set of spheres is an ancient idea that held sway for many centuries. And some people thought that the spheres were actually made of some kind of crystalline substance. And it was generally believed that the Earth was fundamentally different from everything else, beginning with the moon on out to the other planets and the sun. So that on the Earth, there were ordinary things. There was earth and water and air and fire. And things moved on the Earth pretty much in straight lines. And everything on the Earth was subject to change and decay, death. But in the heavens, everything was perfect. And things moved in perfect circles. And so all of the heavens were made of a fifth essence, a quintessence, which was fundamentally different from anything on Earth. So we were at the center, but it wasn't really an exalted place to be. It was a sinkhole. It was a pit for everything that was heavy and unheavenly to accumulate. And people developed instruments for measuring the positions of the planets against the background stars to try to understand what the mechanics were of these objects of beauty. And from the ancient Greek world, Ptolemy in the 2nd century had really codified all the knowledge up to that point. And he had to explain why the planets sometimes seem to get brighter, why they sometimes seem to move backwards. And naturally, he had to fiddle a little with the math. And in the Near East, people took issue with some of his mathematics from an early time. People liked the idea of perfect circles. They didn't want bodies moving in any way but perfect circles. And Ptolemy had violated that rule a little bit. And so there was an entire school of Islamic astronomers who looked for ways to preserve the perfect circular motions. And Copernicus actually borrowed some of their math. But he did something that no one else had done in a codified way, which was to imagine what would happen if, instead of thinking that all motion took place around the Earth, if you switched places between the Earth and the sun, suddenly all the motions of the planets made a new kind of sense, because the bodies that would be closest to the sun would move the fastest, and the speeds would decrease in an orderly fashion all the way out at Saturn, which was the last planet, the last of the planets that can be seen with the naked eye. So this was a powerful message to him that he had hit on the actual architecture of the universe. Most mathematicians, astronomers of his day didn't make such claims. They were interested in doing enough math to be able to explain what they saw. But no one wanted to take that extra step and say this is the way things really are, because it was thought you couldn't know that unless such knowledge had been divinely revealed to you. And people were wary of making that kind of claim. Ptolemy, this is Ptolemy. Ptolemy had once suggested that, when you think about all the stars going around the Earth every 24 hours, it strains belief. And it would actually be easier to imagine the Earth rotating and making the stars appear to go around the Earth, except that was too ridiculous even to think about, because after all, it doesn't feel like it's moving. And although you can know the Earth is round, You all know the Earth is round, right? How do you know that? How did people know that? They could tell, if they traveled very far, north or south, there were different stars. If they saw a ship leave, the ship would slowly disappear from the bottom up, and the ships would reappear from the top down. And if they watched a lunar eclipse, and they could see the shadow of the Earth on the moon, it was round. So the idea that we needed Columbus to discover the Earth's roundness for us is a fiction born in the 19th century of the novelist Washington Irving. But there is no experiment you can do on the Earth to convince you that it's in motion. So that is a very tough claim to put across. And Copernicus was nervous about it. And he got the idea when he was fairly young, and he sent out a letter, what scientists did before there were professional journals. They just wrote to a few other people, and people would copy their letters and circulate them to other interested people, and eventually the circle of interested parties would know. And in his letter, he promised that he would put all of the details down in a big book. And then he sat on it for about 30 years until he was finally convinced to publish. And it's hard for us today to realize how frightening it must have been to put forward that idea. Fear of ridicule, and also a fear of religious backlash. He actually was in the employ of the Catholic Church, but he still worried that people would take phrases from the Bible and attack him, because the Bible is very invested in the stability, or rather the interpretation of the Bible was completely invested in the stability of the Earth, that it was set on its foundation, according to the Psalms, not to be moved forever. And of course, there's the book of Joshua. If the sun isn't moving, why would Joshua have to tell it to stand still? So these were worries. And also, from a scientific standpoint, to say that the Earth was in motion, like any of the other planets, was to upset the entire structure of physics, because all the ideas about motion were contingent upon the Earth being at the center and having all these motions in straight lines directed toward the center of the Earth. There was a very practical application of knowledge of the positions of the planets, namely astrology. Every bit as ancient as astronomy. They grew up together. And this is actually Copernicus's horoscope, not something he did. It's unclear from his writings whether he had any faith in astrological prediction. He never says anything about it in his book, but again, he didn't say much. So maybe he was a believer but just didn't mention it. But then why else would he care so much about where the planets were? And this top image was from a very famous prognostication from his lifetime. In 1524, there was a conjunction of Jupiter and Saturn in the sign of Pisces. And the astrologers interpreted this as an end of the world flood. And so here's the fish for Pisces and some of the bodies that were going to be in conjunction, and here's the flood water coming down. And then the flood didn't happen, which often happens with astrological forecasts. So people wondered if they had perhaps interpreted the signs wrong. Astrology was also very important in medicine. When Galileo taught in Padua, he taught the medical students how to cast horoscopes, because you needed to know your patient's horoscope in order to give a good diagnosis and also to know when and what treatments to administer. So each part of the body was governed by a different sign of the zodiac, and then where the planets were at the time of the patient's illness was very significant. There were also comets seen from time to time, but people didn't know whether comets were visitors among the planets or whether they were some kind of atmospheric phenomenon like weather. And of course, it was thought that they occurred below the moon, because if they were beyond the moon, how would they get through all of those solid celestial spheres? So this was a question up until the middle of the 16th century, when Tycho Brahe watched a comet. It was, in fact, this great comet of 1577. And Tycho knew what was really missing in astronomy was accurate observations. Even before the telescope, it was possible to measure by degrees the distances of bodies one from another against the background of the stars. And he felt if he could really perfect the measurements, much more could be done. And he could tell from his judgment where the comet was, that it was definitely beyond the orbit of Venus, which meant that there really were no spheres. So that was a huge change in outlook. And he did this by building gigantic instruments. These are some of his assistants working at this arc here. Beyond, this is actually a painting that he had to show the rest of his observatory. But Tycho did not believe in the Copernican system. He could not accept that the Earth was in motion. With all of his brilliance and all of his contributions, it was still just too weird to have the Earth moving. And he also couldn't believe the extraordinary distance to the stars. Once Copernicus put the Earth in orbit around the sun, people thought, well, the stars should look different over the course of the year. If the Earth is going to move that big a distance, then the stars, some of them should look closer together at one point and farther apart in others. And there was no such change over the course of the year. And Copernicus said, oh, well, that's because the stars are ever so much farther away than anybody ever believed. And that was a real stretch. I mean, that was as big a stretch as saying that we're actually spinning around at 1,000 miles an hour. So Tycho couldn't accept that. And his system had the other planets in orbit around the sun. That's what's going on up here. But then the sun is still in orbit around the Earth. And here's the comet. At the time that, I heard people laughing at this idea. At the time, it wasn't funny. Because as you can see, look who got the bigger crater. You know, when we started putting names on the moon, imprinting our own honor roll of astronomers on the face of the moon, Tycho got the big one. But Tycho had, as an assistant, this person who really did think Copernicus had it right, and was a very early proponent of Copernicus. But it was Kepler, working with the Copernican idea and with the data that Tycho had gathered, who finally figured out that the reason it was so hard to get the planetary orbits to work is that they weren't perfect circles. They were actually ellipses. And he was the first astronomer. Copernicus was the first to unify the whole system and give it a reason. Even though he had no concept of what the force from the sun might be, he knew that the sun was doing something to the speeds of the planets. Kepler really made astronomy part of physics, and he was criticized for that in his own time because, again, you weren't supposed to know how it worked, but he did. And as modern as he was in his mathematics, he was very much a mystic and had visions and believed that the reason there were only 6 planets was because there were only enough perfect solids to fit between the orbits of 6 planets. And that's why there could not be any more than that. And he also had this idea that the tides were somehow caused by the moon, which sounded like witchcraft to a lot of his contemporaries, including this person. Kepler wrote to Galileo early on. It's hard for Galileo to keep up correspondence with a Lutheran in Germany. So people say he was rude to Kepler. He really had a lot of respect for Kepler. And of course, we know from the introductory remarks, if no other way, that Galileo was the person who took what was a toy, a little gadget for seeing what your neighbors were doing, and turned it into the first astronomical instrument with lenses that allowed faraway things to be seen as though they were close up. And when he looked at the moon, which was supposed to be made of completely different material from the Earth, but he could see it was a rocky body. It had craters and mountains, and he could tell by the way there were these little lit up places on the dark side. Those were the tops of mountains that were catching the sunlight before the rest of that part of the moon. And this was the beginning of observational astronomy. It was the first evidence of the nature of what had been just lights in the sky. This is the full series of washes. That he was also a trained and talented artist. And those of you who are accustomed to looking at the moon, you know that if you just look for the moon every day and night and watch where it is and what it looks like over the course of a year, it's one of the best lessons in astronomy. You learn more by doing that than you ever thought possible. But then he found other moons. His most extraordinary discovery were these 4 bodies in orbit around the planet Jupiter. The first time he saw them, he thought they were just little stars that happened to be lined up in a row. But when he went back to Jupiter repeatedly, they kept changing their position. Now they were to the east, now they were to the west. And he made these very careful field notes. And here too, there was a practical application for this knowledge because navigators needed a way to determine their longitude. And they could determine latitude by the heavens, but not longitude. They needed something that would serve as a clock. And Galileo felt that the eclipses of the Jupiter satellites were so regular that they could be useful in terms of helping sailors find their way. Actually, they turned out not to be all that useful, partly because Jupiter is in the night sky only about 6 months a year. So there was a real shortcoming there as a reliable method. But the moons were put to use in mapping, but on land. And this is a map. Well, you can tell it's a map of France, but this faint outline was the old map of France, and then when the astronomers learned how to use the moons of Jupiter, they redrew the boundary, which is why Louis XIV was overheard to say that he had lost more territory to his astronomers than to his enemies. But this worked. And Galileo, of course, used the discovery of the moons of Jupiter to show that the Earth was not the only center of motion, that obviously there were these bodies going around Jupiter. And a big impediment to the motion of the Earth had been the moon. People knew the moon was orbiting the Earth. How could the Earth move through space and take the moon along with it? Well, Jupiter was doing that with 4 moons, so obviously it was possible. And so he began loudly supporting Copernicus. He'd been timid before that, but he came out loudly in favor, and of course drew down the authority of the church. And it was only because of Galileo that Copernicus's book, which had been out for about 80 years by this point, wound up on the index of prohibited books. And in this artist's conception of Galileo showing his discoveries to the Roman college, here is Jupiter with its 4 little satellites, and here's his picture of the moon with its terminator line rough because of the rocky surface of the moon. But he also made another extraordinary discovery which involved the phases of Venus. This is another part of one of Lynette's images. And he felt that that was really serious proof of the motion of the Earth and of Venus's interior position and the motion of both planets around the sun. But everyone still believed there were only 6 planets until Herschel came along and in 1781 found what he thought was a comet, because the idea that there could be more planets to discover was bizarre. But in not too much time, it became clear that this object was actually a planet, and it doubled the size of the solar system. And in watching the behavior of what became known as Uranus, there was a big flap over what to name it, but its orbit was a little odd, and since a 7th planet had been found, it was easy to posit an 8th one beyond that could be causing the anomalies of the orbit. And Neptune was actually discovered on paper by 2 mathematicians before anyone ever saw it through a telescope. So it was new bound. The solar system was getting larger and larger, and our place in it was not only not central but small. It's good to keep that in mind, that smallness. But you know, Copernicus always gets blamed for removing humanity from the center of things. But as I said, the center wasn't really the great place to be. You know, after all, God and the angels were out beyond the stars, as far from the center as you could possibly go. Here's some more reality check for the size and significance of our place. So if there were 8 planets, why not 9? And this person, Percival Lowell, first looked at Mars and got very famous for finding canals on the surface of Mars and for positing a whole race of Martian creatures who were dying of thirst. And they were building these canals because their water resources were disappearing. And so they were highly intelligent, but in danger. And Kepler had actually written a little science fiction. He imagined a journey to the moon that would enable people to see the Earth from the perspective of the moon. But Lowell's ideas about Mars went way beyond that, and that is partly why Mars became the science fiction planet. And here's Lynette again. My Mars chapter was about science fiction. So this was Lowell's Mars with lots of canals, detailed features. And this is our more modern image of Mars as a place that was once a wet world, but also a place with all sorts of possibilities for Martians, for art becoming reality. And this, here's the Earth up in the distance. And this, of course, is the famous Mars rock that stole headlines in the mid-90s for seeming to once have harbored a form of alien life. Still a famous, exciting thought. But going back to Lowell, he also started a search for a ninth planet, which he didn't live to see, but this man, Clyde Tombaugh, was hired in his youth to go to the Lowell Observatory in Arizona and conduct this very detailed hunt for a ninth planet. And these are the discovery images. So he was taking these plates of the night sky and then comparing them to see if any of these tiny dots ever changed from one image to the other. That's how he was able to discover what became known as the planet Pluto. We don't call it that anymore. But that was the last body to be discovered that way. And of course, everybody here has some connection to the age of actually going to the moon, not being content to look at it from afar, but being there, establishing a human outpost on another world. And that certainly was a colossal change in our sense of the solar system and of the universe at large. And it forced a way of thinking about what else was there, where else might we live, what other beings might live elsewhere. And in 1961, Frank Drake initiated the first search. It was a very small scale search, but a search for radio signals from an intelligent civilization elsewhere. And so when the Pioneer 10 and 11 spacecraft were being built to actually leave the solar system, Frank Drake and Carl Sagan and Linda Sagan designed this image to be affixed to the spacecraft as a message to someone about us. And they got a lot of flack about this image, but their view was it was really a message to people on Earth to start thinking about how we would explain ourselves, how we would account for our behavior, our stewardship of our planet to beings from another world. And it's still something to think about, because sometimes I think we're not doing very well. The Pioneers were followed by the Voyagers, and the Voyagers made some very exciting discoveries in the vicinity of Jupiter, going by Galileo's moon and actually witnessing a volcano in progress. And the Voyagers were followed by the Galileo spacecraft itself, which completely changed our view of the Galilean moons of Jupiter. We've come to know them in fantastic detail. Here was Lynette's take on Jupiter. I had talked about astrology in relation to Jupiter, because in astrology, Jupiter is the beneficent planet, the most powerful force of good. And the horoscope on there is the chart for the Galileo spacecraft. You can do that. You can cast a horoscope for an inanimate object. And of course, one of the things that Galileo, the spacecraft, discovered was a vast ocean on the moon, Europa. It's the first time anybody had discovered an ocean in 500 years, so it was a big deal. And people got worried that if this spacecraft was allowed to just decay in orbit, it might someday blunder into Europa and maybe kill something coming to life in the ocean, or at least destroy a pristine environment. So they intentionally, while they could still control it, sent the spacecraft on a collision course for Jupiter, which is why it's depicted almost as a ghost spacecraft here. And you know, what was funny about this horoscope was you see little squares in the center that describe some of the relationships of the planet. Square is very bad in a horoscope. And there was a square aspect between Mercury and Jupiter. Jupiter is the spacecraft's partner in life. And Mercury is the planet that rules communication. And if you remember, the launch of Galileo was held up because of the Challenger disaster. And so nobody realized that it had been damaged in storage. And when it finally was released, that giant antenna didn't open all the way. And there was a lot of reprogramming from the ground that had to go on. And then there was a tape recorder on board that was supposed to store data. And that also had problems. So communication problems, bad aspect. I don't know, it gives you something to think about. And now Juno was launched recently on the way to do more studies of Jupiter. And look who's going along to Jupiter. These guys got a lot of press. Here's Galileo with the planet Jupiter and his telescope. And here's Jupiter, Zeus himself with a thunderbolt. And this is Juno with her, she's looking closely at things, trying to see what he's up to. You know, remember that? She's kind of been cleaned up a little for the new age. Things have changed a lot. Things have really changed a lot, not always for the better. This is why a lot of people don't really know what the planets look like in the sky anymore. And it's very difficult to find a good dark sky observing spot to look at the natural beauty of the heavens, which is why we're more dependent than ever on spacecraft that can see through clouds, as Magellan did, looking through the clouds of Venus, and creating a global crisis in nomenclature. Suddenly there were all these features that had to be named. That was exciting. And this interesting spacecraft now on its way to Pluto, which was a planet when the spacecraft took off. See, even in recent times, our relationship to the solar system keeps evolving, because once people knew about all the kinds of things that were in the Kuiper belt, Pluto started looking less and less like the 9th planet and more like the premier object of the Kuiper belt. So it became necessary to come down hard on the word planet, which struck a lot of people as strange. You know, after all these years, what was it really? And it's an ancient term. It just means wanderer. But once there was a question about what was a planet, even in our own solar system, and when exoplanets became reality, was even more important to have a definition everybody could agree on so that you could say what was what in terms of what was being discovered. I actually got invited to serve on the Planet Definition Committee, and I was really thrilled. I was the only non-astronomer. We all look terrible in this picture, by the way, but it was a historic moment. And I remember my older brother saying to me, you know, why do they want you? This is a scientific decision. But they were interested in the public reaction. And I didn't have any particular feeling about whether Pluto should be in or out. Like the others, I wanted to see a definition that would work and that would be serviceable. And by our definition, Pluto would have remained a planet. But you all know what happened. There was a vote at a meeting of the International Astronomical Union, and our criterion was it was an object in orbit around a star that was big enough to have gotten round. But then the third criterion added was that it also had to have cleared its neighborhood, on which grounds Pluto was no longer a planet. So that was my moment. But we still have New Horizons going there, and whatever we call whether we call Pluto a planet or not, it's still a really interesting place, and everybody is glad that we'll learn more about it. There are other wonderful spacecraft out there right now making discoveries. Cassini at Saturn. The rovers, opportunities, a literal cliffhanger in our own time. Is it 8 years of this 3-month mission? Truly remarkable how people have related to this object just trekking its way around Mars, and probably will have even more identification with the new one almost on its way. And we have Messenger at Mercury, a phenomenal achievement, getting a spacecraft in orbit around a planet that close to the sun. Unbelievable. And in recent news, on the exoplanet front, a planet orbiting 2 suns, like something out of the Star Wars movie. And it just goes to show that almost anything we can imagine is probably out there, which is our relationship now. And the more exoplanets that are discovered with the Kepler spacecraft, there are hundreds upon hundreds, and average people are being called in to help interpret the data, a real participatory exercise. And our own solar system now is not unique, and yet it is the template by which we think about all the others. And we describe Jupiters when we talk about giant planets of other stars. And we keep looking for an Earth. And that is something we might all yet get to see. And that will really change our relationship with the solar system and everything else. So, thank you very much. Be happy to take some questions.